Should I start now?
Yes, I can see your screen. And just so you know, Professor Saad, we had a little bit of a mix-up with the links we sent. So we did send the correct link out just recently. So maybe some additional students will connect because the previous link, I think they were not able to use it. So, but that's okay. We'll send a recording of this to anybody who was not able to participate. So welcome everyone, and Professor Saad, thank you for being here, and we're ready to go whenever you are. Thank you.
All right. So today for the topics, there was 3 topics that we're covering. We're doing algorithms, and complex numbers. And the third one is trigonometry. So starting with the algorithms first. Oh, sorry, logarithms. My bad, I wrote the wrong side. Logarithms. All right. So a logarithm, basically, I think, like if you're familiar with the exponents, let's say we have a number 2 to the power 3, the answer would be 8, because 2 times 2 times 2, we get the 8. But let's say the logarithm do the opposite of that, right? So logarithm is the inverse for the powers, for the exponents. So the logarithm, if we do the log, let's say we have something, a number a whose power is b, so the answer is equals to something x, right? So then when we do the logarithm, the log tells us the log, this a goes into the base here, log a of that number x. The log of that number x is equals to b. For example, in this problem here that we have here, see 2 to the power 3 is equals to 8. So log with the base 2, and for 8, log base 2 for the 8 is equals to 3. This tells us that the power, what should be the power for the 2 when we do the logarithm? That gives us 8. So when the 2 to the power 3 will give us 8. So that tells us the powers, the exponents. And there's, okay, so, okay. And there's one more thing, we cannot do the logarithms, like you cannot put the negative number, let's say log ax equals to b. So x cannot be a negative number. And the reason for that is, like, no matter, because the powers, let's say we cannot get the negative as the answer, right? In x here, you cannot put the negatives.
Excuse me, teacher,
Yes?
that
Yes.
student Stefan.
Yes.
Student Stephen, I
Please.
needed the repeat for the class.
Yes, I'm saying that we cannot put the negative numbers inside the logarithms, right?
Thank you.
You cannot get the like log 2 of minus 2. That's not possible. You cannot do that. So these numbers are always positive numbers. So let me go to the next page. Can I clear this? Can I clear my writing? Okay.
Yes, we're good, I think.
Okay. So there is some properties for the logs. So the first one is if you have the two logs, log of two numbers, let's say they have the same base, right? Log A, the base A, which is called the base, and this is the number here, log A, log base A, B plus log A have the same base. This one is the base, right? When they have the same base log, and this is, let's say, C, and when they are getting added, you can write them in a single log with the same base, and this B and this C, they will get multiplied. Right? This is the one of the properties that we have here. Then there is another one, which is about the divide. Like when we have the same thing, but the scenario is a little changed, there is a negative in between. All right. There is a negative here. Right? So these like the bullet. So we have, then we can write it again in a single log with the second one, the one with the negative sign, will be in fraction down there, will be dividing here. Then we have another good property of log, which says that, let's say we have this log and it has some power in here, let's say 2, or let me just write it in general. The power, let's say it has the power n. So this power n, it can be written in the start and everything else. Let's say, for example, if I have log 3 and there is 9 to the power 2, I can write it like this: 2 log 3 and then 9. So this power can go in the start, and it's two-way around. Like if it's in the start, you can also write it from this way to this way, or like both ways. You can do it, switch them both ways. It's two-way thing. All right. And there is okay, and there is another thing which is called change of base. Let's say we have the base log, let's say this is A and this is X. Sorry again. So I was saying, let's say we have log A and this is X. We can change the base of the log by doing, like, let's say we want to change this into base 10. Instead of base A, we want to change it into base 10. So log 10 X divided by log 10 A. So log A, when we normally see the log on the calculator, wherever you see the log without anything written, just like on the calculator, that's normally log base 10. So if we want to convert any base into the log 10, base 10, we can do that formula. All right. x over 0.5 equals to log 3 5x minus 1 over log 3 and then so let's start on both sides. Okay. So now let's start with this. So this 0.5, we can write it as 1/2. Two, right? And on the right side, we have log 3 5x minus 1. And okay, now the answer, we can solve this, all right? So log 3 to the power 9, you can use calculator, or if you know it yourself, you can just do it yourself. The answer for that thing is 2. Why its answer is 2? Because 3 to the power 2 is equals to 9.
La sala y me
So,
perdí un poquito de la clase.
the log is telling us that log 3, like what was the number when if we have the 9, what was this number here? So that's 2. Okay, you can use calculator if you don't know yourself. All right, so this is 2 here, and this 1 over 2, this 2 will, we can move this 2 up there. Get log 3 oh, how is it
Roxana,
2?
Roxana, please mute Mateo
How is it
or
2?
Daritza. Daritza, are you there? Please mute
Because
Mateo.
log tells us what is the power. What is the power of 3 that gives us 9? That's what the log telling us, the thing. So 3 to the power 2 gives us 9. So that's why the answer is 2. So log and then x, this 2 will go up in the fraction. So it will be 2x equals to log 3 and then 5x minus 1 over 2. Oh, sorry, this 2 is over the whole thing. 2 is over the whole thing. Then we cross multiply this 2 on the other side here. We cross multiply the 2 on the other side there. We get 2 log 3 2x equals to log 3 5x minus 1. Right, then this 2 is outside, so we apply the power rule. We will apply the power rule, and this 2 will go into the power here. Okay, so now there is one more thing. As I told you, the log is the inverse of the powers. Like if we want to cancel out a square, we do the square root. Similarly, if we have the same log with the same base on both sides, we log 3 and a log 3 here. If we have this kind of scenario, we can get rid of these logs by writing them, by taking the 3, by writing them in the power of 3. This thing, like the answer of this thing is actually just, they just cancel out each other. Okay, like power and the log 3, they cancel out each other. So what we will do, we will write the both sides in the power of 3. Because whatever we do on both sides of the equation, the balance do not disturb. We write both sides of the equation in the power of 3. So the balance is not disturbed. The equation is not disturbed. It's still same. So this log and this the thing cancels out. So we get 2x squared equals to 5x minus 1. We can write it as 4x squared equals to 5x minus 1. So that's how we can solve this. We solve this logarithmic problem, and now it's just a equation. It's a quadratic equation. The quadratic equation is 4x squared plus 5x. Wait a second. It was 5x minus 1. So you move that to the other side. All right, and I assume that you might know how to factorize, or if you don't know how to factorize, you can use quadratic formula or quadratic equation to solve this, but you can factorize it by breaking it into minus 4x minus 1x plus 1 by doing the factorization. For factorization, we see what is the product of this number times this number, that is 4, and the sum should be minus 5. So the sum is minus 5, minus 4 minus 1 is minus 5, and when we multiply them, we get 4. So 4x squared, oh sorry, so we take out the 4 as common factor, 4 as a common, 4x as a common from these two. It will give us x minus 1, and then we take the 1 common from, actually minus 1 common from these two. It will leave us with the x minus 1. So we get 4x minus 1 and x minus 1. That will leave us, the first one isn't 4 times 2. Wait, sorry, Stephen, I didn't understand your question. We're not doing 4 times 2. No, this is squared. This is squared. X squared, not times. This is the power in the x. So then we get, then we write them equals to 0 separately, because when two factors are equal to 0, you can write them equals to 0 one by one. Then from there we will get x equals to 1/4 and x equals to 1. So that these are our two solutions for that question. Okay, so there is many other things, but like we have to cover 2 more topics, so we'll just move on. Okay, should I move this? Can I go to next one?
Yes, Professor, please go ahead.
Okay. So next one is complex numbers. Complex numbers. So the thing with the complex numbers is the idea starts from here. Let's say I want to do the square root of 4. The answer is 2. But if I want to do the square root of -4, I don't know the answer, because I don't know what is the square root of a negative number. If you put it into the calculator, it gives you an error. All right, so how to deal with that, what to do for that? So to solve that problem, there comes the idea of complex numbers. So the complex numbers, so what they did, they give the name square root of -1. We cannot find its value, but we can give it a name, just like our names. Like we all have a name. So this square root of -1 have a name. It's not its value, it's its name. It's called I, or it's read as iota. Iota. Okay. So the square root of -1 is iota. So this is what the I is. The complex numbers are represented in this form. The z is equals to a plus b I, where a, b, they belongs to the real numbers, like their numbers 1, 2, 1.5, 2.5, anything. All right, like any number, square root 2, square root 3, it can be anything. A and b are the real numbers. Now let's look at this thing again. We know that the name of the square root of -1 is I, right? But if I do the square on both sides, on both sides, the square and the square root will cancel out. So I square, iota square, is equals to -1. Okay, so so when we have the complex number here, this a is called the real part, and the b iota is called imaginary part in this one. So I squared, we got the I squared as -1. All right, so now if I again multiply the I squared, with an I squared times I, that will be equals to -1 times -1 square root. Okay. So I times I will be I cubed, and -1 times anything is just minus square root of -1, right? We don't need to write 1, which is equals to -I. So I cubed is equals to -I. All right. And again from here, if we do the square of I square here, I squared square, the red one, I'm writing with the red pen. So -1 squared. So what is the square of -1? That will be 1. And square times square will be 4. So we get I to the power of 4 is equals to 1. So I to the power 4 is 1. I squared is -1. And I cubed is -I. So these are the powers of, like, these are basic powers of iota. Okay, then let me just do, okay. So we can add them, we can multiply them, divide them, just like the normal. Let's say we have a complex number z1, a plus bi, and a complex number z2 equals to c plus di, right? So we want to add them, so add them, a plus bi plus c plus di. So this I and the I terms, they will add up, and the numbers without the I, they will add up. So it will be a plus c plus bi plus di. Let's say now we give them a numbers, a, b, c, d, any numbers. Let's say we have 2 plus 3i plus 5 plus 2i. So 2 plus 5 will be 7 plus, and then 3i plus 2i will be 5i. So that's how we just add them, and by the same rule, we can subtract them. All right, same rule, just like the same the numbers will be subtracted with the numbers, the I parts with the imaginary part will be subtracted with the imaginary part, and the real part will be subtracted with the real part. All right. Similarly, we can divide them and multiply them. So let's multiply them quickly. So we have number a plus bi. We want to multiply it. We want to multiply that number We want to multiply that number with the second number, c plus, all right? We are multiplying them. So we use the FOIL rule, a times c, a times d plus I, right? So a times c plus a d I, all right? And then we do this and that, plus b c I and b times d I squared. And if you remember, the value for the I square is -1. All right, so we will have AC plus ADI plus BCI, and this I square is -1. So plus BD times -1. So this will become, so it will basically become, AC plus ADI plus BCI minus BD. So that's how we can multiply. Like instead of now A, B, C, D, they are representing the numbers, right? They are the dummies for any number. So like when we will have the numbers, actual numbers, we will just multiply the actual numbers instead of these. Like these will be replaced with the numbers. And there's another thing. If we have, let's say 2 over I, we cannot have this I in the denominator. We do not leave the I in the denominator. So we have to get rid of that from the denominator. So to do that, what you do sometimes, like you just multiply it with its, okay, so it's just like rationalization. It's just like the rationalizing the square root. Like if we do not want the square root inside in the fraction down there, the way we rationalize it, it's the same thing, right? So let's say I have a question here, 5 plus I square root 3 over 1 minus I square root 3. Okay, so now there's a problem. This I is in the denominator and we do not want it there. So to get rid of that, what you do, you multiply it with its conjugate. So z, it's z, the number, its conjugate is, let's say we have the z, it's written like this, it's z conjugate. So we had the z is the number, complex number, a plus bi. So its conjugate, the z, is actually equals to a minus bi. The I term, you flip the sign of the I term. It was plus, you made it minus. So that's the conjugate. So what we do when we want to rationalize it, when we want to get rid of it from the denominator, we multiply it with its conjugate. So let's do that. So z, so we don't need to write the z anymore. So let's just do it. So it will be equals to 5 plus I square root 3 over 1 minus I square root 3. We multiply it with its conjugate, which will be 1 plus I square root 3. But since we know the rule, we cannot just do it on one way. Like we are not allowed to multiply anything by ourselves. So to balance it, we also need to multiply it on the numerator, because you see, we can still cancel them out. Like this one and this one can cancel them out and they are still 1. So we did any change in the question. So now let's multiply them. Okay, so we will apply the FOIL rule that we just learned for multiplication. So 1 times 5 will give us 5. Then 5 times I square root 3, so it will be I 5 square root 3. Now I square root 3 times 1, that will be 1. So I square root 3 and I square root 3 times this. That will give us, I times I will give us I squared. And the square root 3 times the square root 3 will just give us 3. Now we multiply the lower ones. I times I, 1 times 1 is 1, then 1 times plus I square root 3, and then minus 1 minus I square root 3 times 1 will be minus I square root 3, and then we multiply this times this. That will minus plus times minus is minus I squared. Square root 3 times square root 3 will be just 3. So now let's combine the like terms, as I said. So this is 5, it's a number, but the I terms, we will see if we can add them, right? So this is 1, and this is, so we have I square root 3, and this is 5I square root 3. So that will add up to 6. 5 plus 1 will be 6I square root 3, because they are the like terms. And I square is minus 1. So that will be minus 1 times 3. Okay. And now you see this one is with minus and this one is with plus. They can cancel out. And I square is actually minus 1. So we will have 1 minus 1 times 3. Okay, let me just write it the final step here in this. I'm just writing the final step here. Yes, I can repeat that. Okay, so what we did here, this was 5. This is a number, and I square root 5I square root 3. This is different thing. This is with the imaginary item I. So we cannot add this with the 5, but I square root 3 and 5I square root 3, they are like terms. They are same terms. So we can add them. So it will be 5 plus 1 will be 6. 6I square root 3. And then I square, its value is minus 1. So it becomes minus 1, right? Here it is. Minus 1, or you can just leave it as minus. It's the same thing. So minus 1 times 3, or just minus times 3, that's the same thing. And then in the lower one, this is plus I square root 3 and minus I square root 3. So they cancel out. So I get 1 minus I square and then times 3. And the value of I square is minus 1. So that's how I got the minus 1 here times 3. Now we just simplify it further, one more step. So 5, and this is minus 3 actually now. Minus 1 times 3 is just minus 3. So 5 minus 3 will be 2 plus, we can write it 6I square root 3. And this one minus times minus will become plus, right? Minus times minus is plus.
Excuse me, teacher, can you repeat that? Because a student, Stefan, have a question about that.
Yes, yes. Okay, so let me write it for you again. What we did, we want to get rid of this square root. We want to get rid of the square of this I from the denominator. We do not want it in the denominator, right? So to get rid of that, we need to multiply it with its conjugates. This is the z conjugate. If we have a number, z, complex number, we want to find its conjugate, we change the sign of the imaginary part, right? So I had 1 minus I square root 3. So I multiplied it with 1 plus I square root 3 by flipping the sign with its conjugate. But since we cannot just multiply the denominator, we also multiplied the numerator. Then we applied the FOIL rule. The FOIL rule for the multiplication. First we 5 times 1 and 5 times this thing. Right? Then I square root 3 times 1 and I square root 3 times I square root 3. Then in the bottom part, I did 1 times 1, which is 1, and 1 times minus I square root 3 or plus I square root 3 right there. And then minus this times this and this times this. Then in the next step, I combine the like terms. I5 square root 3 and I1 square root 3, they are same I terms, imaginary terms. You can add them. So 1 plus 5 is 6. Then I square, the value of I square is minus 1. So we replace the I, we put that minus 1 times 3. So 5 now. So now in the denominator, 1, this one is with the plus, this one is with the minus. So they cancel out. And again, I square is minus 1. So we got minus 1 here. So then we just minus times minus is plus, which is 4. And then the above 5, this is minus 3. 5 minus 3 is 2. 2 plus 6I square root 3 over 4. That's the final answer. After, you can say we was dividing these two, we was dividing the two complex numbers. So we divide them this way. We get rid of the I term from the denominator. Okay, all right. Okay, all right. Let's just quickly have a look at now in the remaining time on trigonometry. Okay, so we have trigonometry. Here. So trigonometry word comes from the trig means the triangle. Actually trigonometry. So it was actually the measurements of the triangle. That what it was literally mean when it was discovered. So trigonometry is like it's where we study the triangles, its sides and its angles, right? So, but okay, so there is 6 basic, like 3 basic ratios in trigonometry that are there that deals with the angles and the sides. Okay, that is sine. Let's say theta represents the angle, sine theta, cos theta, and tan theta. There is tangent. It's also called tangent theta and cosine theta and sine theta. They are represented like this. So let's say if we have a, and let's start with this right triangle. These are for the right triangle, the ratios. Let's start with that. Right triangle is the triangle in which this angle is 90 degrees. In which the angle is 90 degrees, that's a right triangle. And there is our angle theta. Or if theta is a difficult word, I can use A. So this is the angle A here. So the side opposite to the angle A is named as opposite because it's opposite to the angle A. So this side is opposite. And the side which is adjacent with the angle A is called adjacent. And the side which is facing the 90-degree angle, the opposite to the 90-degree angle, it's called hypotenuse. You can pronounce it differently. Hypotenuse. Okay. So the sine ratio. So sine ratio is sine of the angle A is equals to, it deals with the opposite and over, like if you divide the opposite side length with the hypotenuse, that ratio is called the sine ratio. Then if we divide the adjacent side by the hypotenuse, that ratio is called the cos ratio. And if we divide the opposite by the adjacent side, that is called the tangent ratio, the tan ratio. So these are three. There is three other possibilities. Yes, these are the fractions. Yes. So when you divide them, you get the decimal answers too. Okay, so like these were the three basic, and now the three are the opposite of them. Like you could have said, like you could have said, what if I divide the hypotenuse by the opposite? Right? So if we flip those sides, if we flip them, then we get cosecant, 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 and the sine. They are the reciprocal of each other. So that is hypotenuse over opposite, then cos, and it's called secant, the opposite of that. They are reciprocal of each other. That's hypotenuse over adjacent, and then the cot. There is another one which is called cot. That's adjacent over opposite. Okay, so these are the six. So three are the basic, and the remaining three are just the opposite of them, like this. So sine is equals to 1 over cosecant A. Cos A equals to 1 over secant A, and tan of A equals to 1 over cot of A. Right. So these are the basic ratios. Now there is, okay. So for okay. So now let me tell you, there is usually like there is table. They like you can tell, like you might have seen somewhere, like or if not, like let's say sine of angle sine 30 degrees is equals to what, cos 30 degrees is equals to what. So for some angles we have the calculator. Sometimes we can get the answers with the calculator, but similarly we can also get the answers by just by dividing them. Let's say, for example, let's say we have a triangle, a right triangle. Here, let's say this is 3, this is 4, and this is 5. Side lengths, it's a right triangle. So this is angle A here. So we get sine of the angle A will be equals to 4 over 5. Cos for the angle A will be equals to 3 over 5. And the tan for the angle A will be equals to 4 over 3, like this. All right. So you can use the calculator to find the angle. Like if you have some specific angle, let's say you want to find the value for sine angle 30 degree, you can use calculator, sine angle 25 degrees, anything like that. But there is some basic angles that are like, for them you can also use the exact ratios, right? So let me just go to next page. I tell you a quick way to make a table. So like you can, whenever you have to find that, you can make a table quickly for the different values. Let's say this is cos, okay, cos of angle A, sine and tan. Okay. Let's say if we have the 0 degrees, then we have 30 degrees, then 45 degrees, and 60 degrees and 90 degrees. Then you can write down on your, if you're making notes or something. Okay, it's a good way, like, so you don't need to memorize them anymore. You can just like write your own table quickly. So you start from here, then what you do, you just start writing with this. So 0, 1, 2, 3, 4. Just do it up to now, up to 90 here. We'll fill the remaining later. Okay, so first you write 0, 1, 2, 3, 4. Then divide them by the 2. Okay. Divide them by the actually, wait a second, sorry. Okay. Wait a second, sorry. Okay, now we will do the square roots. Now we will do the square roots of them. You just need to memorize this part. Okay. So you wrote 0, 1, 2, 3, 4, then you did the square roots. So square root of 0 is 0. Square root of 1 is 1. Square root of 2 is square root 2. Square root of 3 is square root 3. And square root of 4 is 2. Now you divide them by the 2. 0 divided by 2, 1 divided by 2, 2 divided. Okay. So 0 divided by 2 is again 0, right? Then you get 1/2. And 2 divided by 2 is 1. All right. So that's all you need to memorize. Okay. Then what you do, you just write them in the opposite order here. 1. All right. And then for the 10, just divide the above one by the below one. So 0 divided by 1, 1 over 2 divided by, and you cannot divide anything by 0. You cannot divide 1 by the 0, right? So now let's divide them. So 0 divided by 1 is 0. This 2 and 2 cancel out because they are in the denominators of the fraction. So when we divide them, we get 1 over square root 3. So these and this, they are same. They cancel out, leaving behind 1, leaving you behind 1. And then this 2 and 2 cancel out because they are in the denominator in same place. And then square root 3 over 1 will give us just square root 3. And we cannot divide anything by 0. We cannot divide anything by 0. So that's undefined, or you can put infinity, a symbol for it. Now let's fill in the remaining. You don't need to memorize anything for the remaining part as well. Okay. Now just write them again. This one, then 1/2. All right. Sorry, not the 1/2. Then the next one was square root 2 over 2. Right? Then 1/2, and then 0. So you see, if you look at the 1, it's the same on the both sides. And with the other one, the next one is also the same. The next one is also the same, but there's a minor change. There is a minus with them. Okay. Okay. Like that. And again, this one is also with the minus. So this is a basic table that you can always make if you need to solve any problem. Let's say now if I ask you what is the sine of 45 degrees, you can just look it in the table and the answer is, you go to sine, you go to 45 degrees. So sine of 45 degrees is square root 2 over 2. Let's say I ask what is the tan of 150 degrees. You just look at the table. See, this is the tan. And this is the 150. So the answer for that is minus 1 over square root 3. But for other values, other than these values, like let's say of 36 degrees, you cannot find that with the table or directly. You need calculators for that. Then there is some basic identities. with the trigonometric ratios sine square of a plus cos square of a equals to 1. Then 1 plus tan square of a equals to secant square of a, and cosecant cosecant square equals to 1 plus cot square. So these are the basic identities. Cosecant a square. Okay. All right, so okay, let me, okay, so I don't think you'll get, okay, so let's just quickly do the question. Maybe, do we need to stop now? Do we have to stop now?
Daritza,
Do we have
Roxana,
to
Roxana, Daritza, are you there?
I am here, Snoopers. Hey guys, do you have any question? Everything for you because the class going to be off.
Hi, Professor. Yes, if you like, we can just wrap up this last concept, and we can conclude the class. So if you have something else to conclude, we can go ahead and conclude it, and then we can end the class. If you have something else that you think we should cover now, we can go over by a few minutes. If it's a good place to stop, we can stop.
Okay, yeah, because like now there is in trigonometry there's many other things that they have to know. So like these are the basic identities. So I can like show, maybe like can try to do one question, show them how to use them, and then can stop.
Okay, fantastic.
Okay, so let's say if we have sine 4a, that's the question here. Sine to the power 4. That's not sine 4. Sine, that's a power. Let me change the color. Sine to the power 4a minus cos power 4a plus 1. And we want to prove that, oh no, sorry. We want to multiply it with cosecant square of the a. And we want to prove that that's equals to 2. So obviously we cannot, like it will be too hectic to prove, like if we take this 2 and we try to prove it equals to that, that will not be like too difficult and not a good approach. So we will take this side, that's on the left side, and we will try to prove it equals to 2. Right? So first of all, I write this sine squared a squared. I can break the power 4 into the square and the square. I have the left hand side. That's equals. Now, if you know a squared minus b squared, a squared minus, oh yes, I wrote the sine square, sine to the power 4 as sine to the power 4 as sine squared 2 and 2. Okay, cos 4 as cos squared. Okay,
Teacher,
and
a student have a question about that. Can you repeat again, please?
sine squared a, once we have, like, there's a rule, there's a property, a squared minus b squared, we can write it a minus b, a plus b. It's in the algebra, like it's the rules. So we get like this, sine squared a minus cos squared a times sine squared A plus cos squared A. That's like A and B rule, right? And there's plus 1 and cosecant squared A. So as I told you the identity before, if you look up, sine squared A plus cos squared A is 1. This thing is 1. So 1 times the sine squared, this thing will become the same thing. So we will have sine squared A minus cos squared A plus 1, right? Because this thing is 1 in the identity here. And then we are multiplying it with then we have this sine squared A minus cos squared A. So if we manipulate the above one, if I manipulate this one, I want to find what is the value of cos square A. That will be, I move the sine square to the other side. So cos square A equals to 1 minus sine squared A, right? So I replace this cos square A as 1 minus sine squared A. Minus 1 minus sine squared A. Okay, and then plus 1 and then cosecant squared A. So then what we do next is we distribute the minus inside. Minus 1 and then minus times will become plus and then like 1 and then times cosecant squared A. All right, there's a 1 here. So this plus 1 and the minus 1, when we distributed it inside, it cancels out. So this and this cancels out. We will get 2 sine squared A, 2 sine squared A times cosecant squared A. So if you remember, I told you cosecant is 1 over sine. So it's 2 sine squared A times 1 over sine squared A. Cosecant is 1 over sine squared A. So this and this cancels out, and that gives us 2. So, oh, sorry. I just want to write it somewhere. Okay, let me write it. So answer was, it's like, okay, so we get 2 right here, because this and this cancels out. So that's how we proved it. It's equals to 2. So by using the identities. I know there is many things. I just went over very fast over many things, but so we can stop here.
Perfect, Professor Saad, that was great. I think you covered very well these topics, and for our students, we'll make this recording available to you if you have any questions, if you want to go back over it. But more importantly, also to share, Professor, is that our students can go to their trigonometry lessons and courses, to go over some of these concepts with more time and more detail, or more step-by-step. And this is kind of a complement to that. And our students all work asynchronously. So some of the students today might be in Algebra 1, some might be in pre-calculus.
Okay.
So they're not kind of going in sequence. So everybody kind of is in a different kind of stage, but this is still useful because we can archive it for other students to use it when they get to this point in their lessons. So thank you very much, Professor. Yes. And thank you, students, for joining us today.
All right.
Thank you, Teacher Saad. Thank you to all of you, the students. Everything is
Hi, Lourdes.
clear. Hi,
everyone,
Ricardo.
that is Lourdes, by the way, that you're hearing.
Thank you. I received the email from a student that everything is clear. Teacher Saad, congratulations. And thank you, guys. And be pending to the next meeting for today. It's in Spanish, and be pending for the schedule.
All right.
That's right. Today Today we have a Spanish at 3 o'clock, mathematics in Spanish at 3 o'clock, and tomorrow at 10 in the morning, we have, tomorrow at 10 in the morning actually is science in English, and Friday is science in Spanish at 10 in the
In
morning.
Spanish,
So
yes.
that's right.
Okay,
Thank you.
guys.
Thank you,
Thank
guys.
you. Have a wonderful day for all of you. Bye-bye.
Ciao.
Bye.